Hey everyone, this is Nate coming at you with video 4 in my associate level series. And today we're going to be talking about programming theory and concepts. I know this is the video that most of you have been looking forward to, but we kind of had to touch upon the communication as well as interpersonal and professionalism skills. They're almost necessary, a foundational skill if you already haven't uh, practiced or learned those skills. So I wanted to touch upon that prior to getting to this. And hopefully my mic sounds a little better. I was having issues with my old mic. So hopefully we're past that and we'll move into the future with a good mic. So anyways, let's get right into it. So there are hundreds, and I mean hundreds of programming languages in use today. There will be even more tomorrow. It's almost scary. It's overwhelming. So where exactly do we start? I'm brand new. Where do I start? What language do I learn? Which is the best one? That's one of the most often asked questions out there is, which language should I learn? On the next few slides and videos, I'll be giving you a rundown about everything and anything relating to programming. So hopefully you can make better decisions. No one language is perfect, but a lot of people have their preferences and for specific reasons, and I can understand that. So I apologize in advance for this video kind of being a little longer than my other ones. I try to keep them short. However, this one has a ton of information that we need to cover, and like I said, it's very foundational material. So make sure you have a notebook out. You can take some notes, and then you can review them after the video, because once we move on, it's going to be hard to catch up if you don't understand already. So make sure you review the material, you learn what you need to learn from this video, and then I'll see you in the next one. So let's start covering some material. So what is a computer language? Well, at the very basic level, everything that you work with on a computer consists of a program. Pretty simplistic, I know. So the operating system that you're working on right now is a giant program. Your email is a program. The Word document you just created is a program. The web browser you are watching this on is a program, and even the calculator that you do math on is a program. Kind of get it? So all these programs may be programs on top of other programs, and it can kind of get complicated. So the entire premise of programming is the need to solve a problem. The need for email was due to the lack of communication between peers at work, businesses, or everything in between. Sending your buddy a funny joke. The need for a computer program was needed because, well, people needed an easy way to do math, and instead of lugging a big calculator at the time around, they had a thing called a computer, and they figured, hey, why don't I do math on a computer? So everything, and I mean everything on a computer, is a program, and they all have been created to solve a problem. So computer programs are collections of instructions that tell a computer how to interact with a user, how to interact with computer hardware, and how to process data. So having said that, how do we write a program? Well, in the early days of programming, programmers worked with instructions very close to the hardware. This was often called working with machine language. These type of machine languages were very difficult to work with, as well as they weren't very portable. And when they were still very complicated, and it took often years to learn these languages. And even then, you still weren't a master. With the evolution of programming, the development of higher level languages began to take hold. We evolved. So as programming evolved, we began to see programming languages such as C, C++, COBOL, Fortran, and even Java. These high level languages can also be considered compiled languages because you need a compiler to translate the instructions into machine language. There's also something called interpreted programming languages, which are similar to high-level programming languages in the aspect that they're easier to work with. So these interpreted languages can consist of Visual Basic, Perl, Python, the shell scripting languages. So you would often script in environments such as Unix, Linux, maybe even on Mac OS. So which language should you learn first? Well, there's no one set language for someone, but I prefer to strive and tell new beginners and new learners of programming to learn about object-oriented programming languages first, just because they're a tad bit easier to learn than anything else. This general foundation will help you branch off to more challenging languages. So there are two types of programming models. You have the structured programming model, which is when blocks of code and instructions are executed one after another. And then you have object-oriented programming, which is when data is contained in objects. These objects are accessed using methods specific to that object. So object-oriented programming, like I said, in our case, Java, is quite often the first language taught to prospective programmers. And it kind of gets you acquainted to the programming mindset. Java, in our case, is modeled to the real world and the objects within it. Hence why most opt to learn Java first, because most people can relate to the objects and concepts that are seen. This may all sound foreign right now, but I'll clarify all this in the next few videos. So in the meantime, make sure you jot down all the notes that were seen in this video. Make sure to review the material, and I'll see you in the next video. Thanks, guys. So hey guys, thanks for watching. Make sure you hit the like and subscribe button. See you in the next programming video. Bye. Thanks again, guys.